All right, so we are simplifying radicals. We're just going to start with the basics. Today for bell work, we actually had the basics, and that's writing all perfect squares 1 through 12. So in that first box up on top where it says main ideas, I want you to do it again. I want you to do 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. And I erased it on the sideboard for a reason. This needs to be memorized. Tomorrow you have a quiz on it. So let's go through 12. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. You guys have these all memorized already?
Yeah.
10 squared equals 100. Ooh, I'm running out of space. 11 squared equals, who knows it? 121. And finally, 12 squared. Yep. All right. So get those finished. Maybe like another 10 seconds or so. Your quiz tomorrow isn't going to be straightforward and basic. I'm going to make you think. Your quiz tomorrow is going to look something like this. The square root of what equals 7? And your job is to put in the blank space. So what are you going to put in that blank space?
63, 49.
49. So that's what your quiz will be. Blank and empty square roots, and then I'll have the number here. Okay? So you have to just kind of think differently about it, but if you've got it memorized, it's going to be easy. Okay? So something that we need to kind of just make sure to review, what if I gave you the square root of 9? What is the answer? 3. Good. It's not square root of 3. No, no, no. And that's something that a lot of people mess up on. It's just 3. It's no longer in a square root at all. All right. Square root of 100, what would I write?
10.
Just 10. That's all you would write. Okay? No more square root, just a 10. All right, so what we've got here is we've got numbers that are not perfect squares. So this 63, for example. On this 63, it's not a perfect square, but here's what I need, and put this on the margin or somewhere. You need to pick, because today we're going to break it down. No, you must break it down using perfect squares.
I think I remember that. I don't.
So that means perfect squares are those numbers that we just wrote down up above. 4, 9, 16, 25. Those are the perfect squares. A number that can be square rooted perfectly. That's a perfect square. Even 1. So 1, 4, 9. Let me write them. 1, 4, 9, 16, 25. And those are the ones we're going to use most commonly. So when I look back at 63, you got to pick a number that's a perfect square, my list at the bottom, that goes into 63. So what makes 63? 9 times
7.
Okay, so do this. Square root of 9 times 7. Write that underneath. So we just broke it down. 9 is our perfect square. The reason I'm making you pick perfect squares is because now the square root of 9. What's the square root of 9? 3, and it's out of the square root. So I'm going to draw a little arrow and say that 3 is gone from the square root because I square rooted 9.
Wait, are we going to quiz on this tomorrow?
No, just 1 through 12 tomorrow. Tell me what's still left under that square root.
7.
So you're going to write 3 square root 7. I also want to introduce you to a fun vocab word. 3 rad 7. The word rad, radical means square root. I can say 3 square root 7 or 3 rad 7. 3 times the square root of 7. It's all fine. The key thing is that the 9 is a perfect square. 9 came out as just the 3, so the 3 is on the outside. That's the biggest point that you need to gather. So let's do 54. what number, perfect square, can you make from 54?
7 and 8.
Neither one of those are perfect squares. And it's 56.
Oh, 6.
Oh, 9 and 6.
9 times 6. So do that again. Square root of 9 times 6. What is my perfect square?
3.
So I'm going to bring the 9 out. It becomes a 3.
But 6 doesn't have a
6, yeah, so 6 is just going to stay under there like that.
Ooh, I get
This is hard.
Wait, why did 6 have a
Do you understand why I took the 9 out?
Yeah.
Okay, so whenever I see a number that's a perfect square, 1, 4, 9, 16, 25, those numbers can be square rooted. So I could have, let's do this one, watch in red, okay? The square root of 9 times the square root of 6. I could separate it if I wanted to. So what's the square root of 9? 3. So 3 is out. Oops. 3 is out. But the square root of 6, I can't do anything with that. So it stays. 3 times the square root of 6. And that's it. And we leave it. We can't multiply it. We can't do anything to it. Let's talk about number 3. 80. That number is bigger. So 80. What perfect square can go into 80?
8 and 10.
8 is not a perfect square. 10 is not a perfect square. Can't pick it.
80 and 1.
4, right?
1 is not good enough. 4 and what?
20.
Good.
20.
Oh,
Okay, so 4 is my perfect square, right? Okay. So 4 will come out. What's the square root of 4?
2.
2. So 4 becomes a 2, and it's out. Okay, now I need to talk to you about radical 20. Does 20 have a perfect square in it?
no.
Actually, it doesn't.
Think again.
No.
1, 4, 9. Does one of those numbers go into 20?
4.
4.
Oh, 5 times.
So I have to break 20 down even further. So here's what I'm going to do. The 2 is going to stay out there. 20 is 4 times 5, yeah? So what's the square root of 4 because it's a perfect square? 2. Take it out as a 2.
Oh, I get you.
Bring down the 2 that was still there, because these are now going to be multiplied on the outside. What is still under square root?
5.
The 5. So let's just do this math. 2 times 2 is 4 radical 5.
Is that all?
And we're done. It does not matter that there's a 4 perfect square on the outside. That's fine. As long as inside the square root is all simplified down the best it can go. Yes?
How do you know if, like, you know those numbers on the bottom, how you said they're perfect squares? How
Yes.
do you know if a number is a perfect square?
You know a number's a perfect square because it's got a number that when you multiply it twice, it's like 8 times 8. So 64 is a perfect square. 6 times 6. So 36 is a perfect square.
So you just keep breaking it down until it can't be broken down?
Exactly. That's why I couldn't leave 20. You would get marked off if you left a 20. 20 is not reduced enough. Okay, moving on. Okay, so on number 4, I've got 2 on the outside and then a radical 72. So the 2 on the outside is just going to stay on the outside. So I don't do anything. But now I need to start using my brain and thinking about 72. 9 times 8?
Yeah.
Is that okay with everybody? All right, sounds good. All right, so 9 times 8. What number is the perfect square?
9.
9. Does everybody see that 9 is a perfect square? Okay, so since 9 is the perfect square, bring it out. Do like that little arrow. Okay, so my 2 is going to stay on the outside. Now I also have on the outside, from the square root of 9, a 3. Then I have square root of 8. Oh, 8 though, 8.
2.
I can break it down.
Yeah. 2, 2.
The 4 goes into 8. So First of all, let's do 2 times 3. Let's just make that. So 6 rad, 8. But we know that 8 can be broken down. Okay. We just have 4 times 2, right, Miguel? 4 times 2. All right. What am I going to pull out, and what is it going to become on the outside?
Make the 4 a 2.
Make the 4 a 2. So now 6 stays. Don't touch it. Now I got a 2 on the outside also, because square root of 4 became 2. What is all by itself inside?
2.
This 2 right here stays under. Square root of 2 is not a perfect square. You can't do anything. So now, final, woo, 12 radical 2.
That was nice.
And here's the reason it took forever. Because we picked 9. We could have said, hey, 36 times 2. 36 is a perfect square. But you guys don't have your 36s memorized. So we had to go slow. Okay? The shorter answer would have been to break it down and say 36 times 2 is 72. Not 9 times 8. Yeah.
How come the 8 stays in the little thingy and not the 3?
Because 9, the square root of 9 right here, this one, is a perfect square. So I
So only the
square rooted
things that
it.
can still be
How do you
reduced
check it?
over and stay in the thingy.
Yeah, if you can't break this down, like this 2 right here in red, I can't go any further, so it stays. All right, number 5.
How do you check your word?
You don't.
Yes, that's hard.
A calculator, you could put in square root of 2 and then multiply it by 12, but we're not going to use calculators for this. Okay, the negative 4 is going to stay on the outside. But 180. Think about 18, guys. You don't have to worry about the 0. Think about 18.
Times 10.
No, 18 is not a perfect square and 10 is not a perfect square.
No, they're not.
6 is not a perfect square and 3 is not. 9. 9 times what?
9 times 2.
It says 20.
20.
Make it.
Venti.
Who said that?
Okay. All right. I'm going to break down 9. It's going to come out as 3. So the negative 4 is still outside. Now I'm putting a 3 with it. Okay. Now tell me about this 20. Can 20, we kind of did one with 20, didn't we? Number 3, look at number 3, guys. How can 20 be broken down?
I can't.
No, 10
wait.
times 2 is not right. 4 times 5.
Oh, yeah.
So do you multiply the negative 4 and 3?
Let's multiply the negative 4 and 3. Negative 12 radical. Let's break down 20. 4 times 5. Well, 4 is a perfect square. So it comes out, you're right, as a 2. I keep the negative 12 there. There is still a rad 5 all by itself inside. Final answer. Negative 24, radical 5. Ooh, 6. What's the square root of 100?
10.
10. That's it.
That's it.
There's a negative sign that stays there, but it's just 10.
Is it negative? Oh. It's not negative 1?
Nope. It's negative 10. My final answer.
No, I'm talking about the one on the outside. No,
Oh, yeah.
two.
You could, okay, fine. So negative 1 times 10. Negative 10.
Oh, duh.
It's fine. That was easy.
We have no square root sign?
No square root sign because 100 is a perfect square. So you take the 100 out. All right, 7. The 8 stays out there. Tell me about 150, though.
3.
Perfect squares. Here they are again. 1. Let's not even include 1. It's a waste of our time. 4, 9, 16, 25,
6 times 25.
30.
Well, I thought 3 would.
6 times 25.
So-
You are rocking this lesson. All right, 6 times 25.
Oh, the 25 could be
The 25, right, can be taken out because it's a perfect square.
5 and 5.
So you just put a 5. The 8 is still out there. What's in the square root now all by itself? Poor 6. So my final answer, let's do that math now. 8 times 5.
40.
40 rad 6. Chris just brought up a good point because he said that, 25 is 5 times 5. What if I had something, let's do like purple real quick. What if I had something like this? It's going to be on the lower right of your screen. Everyone look at the screen. What if I had that? What would I say the answer is?
Negative 25.
Okay, so yeah, it's the square root of 25, but what's the square root of 25? 5. How about if let's do another one in purple. Square root of 2 times 2.
4.
It's 4, but what's the square root of 4? So this is a pattern. This is a pattern, guys. Square root of 8 times 8. It's just 8. So if there's a number that's written twice, it's going to come out as itself. Okay? Because this becomes 4, 2. That becomes 25, which is 5. This becomes 64, which is 8. So if you see a number written twice, you're going to be able to pull that number out. All right, number 8. I think I put this one on your margin. Look on your left margin that I typed for you. Do you see anything that talks about 125 and 3? Yeah. So, the cubed root of 125. It would look like this. Cubed root means something multiplied by itself 3 times. So this is just a 5. Out of the square roots, no little 3. That's it.
So what's the 3 right there for?
To say that it's going to be a number multiplied 3 times.
So it's just telling you the answer?
Yeah, because you know how we don't put little 2's here?
Yes.
Like we could put little 2's in front of the square root, but we don't. It's implied. It's assumed. Square root 2. How about this one? What's the cubed root of 8?
8.
No. What number multiplied 3 times itself is 8?
What's 24?
What number multiplied 3 times itself is 8? What small number?
No.
2. 1.
2 times 2 times 2.
Oh, that's right.
So the cubed root of 8 would be 2. That's how I would write my answer. Okay? Cubed root means it's multiplied 3 times, not twice.
Hey, where'd you get that 8?
I just made it up. It's because I wanted you guys to practice. Okay, let's do number 9. The 3 is going to stay. What's the square root of 36?
6.
Just 6. Out of the square root, no other answer. That's it.
108.
We're good with 18. It's a perfect square. All right, let's go to 10. Cubed root of 8. Oh, we just did this one. What times what times what makes 8? 2. That's it. Not square root of 2. Not 2 square root nothing. Just 2. And number 11. The cubed root of 3 to the cubed.
That's 27.
Okay, 3 times 3 times 3 is 27. But what's this cubed root of 27? Look at your margin, guys. I typed it for you.
3.
3. All right, here's something to take note of. This 3 exponent and this cube right here cancel each other out.
So it's just 0.
It's just 3. The same thing would go if I were to write, what's the square root of 5 squared? What's the square root of 5 squared?
It's actually 729.
Okay. What is the square root of 5 squared? 5. What is the third root of 8 to the third?
8.
Just 8. What is the 17th root of 6 to the 17th power?
6.
Do you get this pattern that I'm showing you? They cancel each other out.
So basically those things are irrelevant.
Well, if it's written, I need you to be able to know, oh, it's just 3. Like on number 11, oh, it's just 3. I don't need to work it out at all. Okay, number 12. There's a lot going on here. What's the square root of 4? Comes out as 2. Now, what's this 3 squared? 9, right? But what's the square root of 9?
3.
So there's that what we were just practicing. The square root of 3 squared. Just 3. 6, no square roots, nothing.
You know what I did is I just did the square root of 3 and then
That's fine too, it gets you. Okay, so flip over. Let's talk about classwork. All right, I'm sure you've noticed that you will not be successful at this lesson if you do not have a good solid times table background, right? So 45, you have to pick a perfect square. Let's write them. 4, 9, 16, 25. Those ones are like the most common. What perfect square, let me put PS, perfect squares. What perfect square goes into 45?
5, 9.
9 times 5. Cool. The square root of 9 times 5. Well, 9 is a perfect square. It comes out. Your answer is 3 square root 5. Number 2, what's the square root of 36?
6.
Just 6. No square root, nothing.
9.
Number 3, what 18 becomes
9.
9 times 2, right? So the 9 comes out as 3. The rad 2 stays. Number 4, square root of 100. That's easy.
10.
20. I know you did that. 4 and 5. The 4 comes out. Square root of 4 is 2 rad 5. 32. There is a perfect square that I wrote on the top of that paper. What number goes into 32?
2.
Not 2 times 5.
8 and 4.
8 and 4 is not a good choice because there's a bigger one.
2 to the 5th.
No.
3 times 8. Don't laugh at me.
That's 24.
Think of a number that goes into 32 that's bigger than 16. So the 2 stays on the outside. 16 times 2. What's the square root of 16? It's 4. I'm not cutting in half. Rad 2 stays all alone. 8 radical 2 is my final answer for number 6. All right, go on to number 7 without me. Keep working.